Good morning, students. I think we're going to have some technical difficulties today, so I'm going to go ahead and give you this lesson on video. So we are looking at day 3 in Unit 1. And let's see here. So housekeeping and reminders. We're going to talk about the online textbook syllabus. Our lesson today is 1 and 2 sided limits. And obviously we won't be working in groups today. And there will be an exit ticket plus the exit ticket from last week if you were not able to do it or did not realize that was posted. Okay, so reminders and announcements. Physical books can be checked out in our school library, so you can do that Monday through Friday this week from 8:30 to 3:30. We are also going to have the digital book. So there were a few of you that wanted an actual physical book, so this is the information for that. I would like you before next class to watch video 1.4 and take notes, and then hopefully we'll be able to meet again and then actually do some of the practice together. Independent practice 1.1 will not be collected. So I asked you to work on that. That is not for a grade. I will not be collecting it. You're going to do this and then check your work in progress with the key that I posted in Schoology. I encourage you to use a different color and redo any problems that you missed, including their process. And then independent practice 1.2 is going to be due next Monday for you guys when class begins. So I will post that as an assignment on Schoology, but 1.2 is in your packet or on the PDF in our Schoology. Okay, the online book, this is our link. When we get back together, I will give you the code. I'm not supposed to post that online, so I will give you the code when we are together. The syllabus, this is the link for our syllabus, and I will be emailing parents today with this link as well. Please read this over and come to class with any questions that you have. Next class, I'll have a little Google form for you to say that you did read it, but please take the time to look it over and see if there's any concerns or questions that I can clarify. Okay, office hours, which if we have this outage today, you might be using Tuesday and Friday, and then Wednesday. Those are all posted in your calendar. And the Zoom link is here with the meeting and passcode. Okay, we're really in the pit. Happy Monday. Here we go. So our learning goal is to evaluate 1 and 2 sided limits from a graph, table, and piecewise function. No graph. You can certainly pause me at any time and go ahead and record this information. Okay, so we have limits graphically. We're going to graph this function and then go ahead and talk about it. So if you would pause me and go ahead and try to graph this. So I can see this is a rational function. And so we have a horizontal asymptote here at 3 because we have a vertical shift of 3, as we can see here. We also have a horizontal, we have a vertical asymptote here at x is equal to 2. So we actually move to the right 2 for this. Okay, so let's go ahead and make a quick table and plot some points to get a feel for what this graph looks like. Okay, so if we go ahead and plug in, let's say we plug in 1, we would have 1 take away 2 is -1, we'd get a 2. So 1, 2, and let's say I plug in 0, we'd get 2.5. So 0 would be up here at 2.5. So if you remember, you're going to have something that has these branches. So here's the first branch, and then if we go ahead and plug in 3, we would get 4 as an output. And if we plug in, let's say we plug in 4, and again, we're plugging it in anywhere we see an x, we would have 4 take away 2 is 2, which gives us a half plus 3, which is 3.5. Okay, so 4, 3.5 would be right here. Okay, so we have these 2 branches, and this is what we're going to be referring to. So I'm going to be coming back to this graph in a moment. Okay, so we're going to plot the point on your graph that you just have in your notes that has the input of x equals 5 on your graph from number 1. Okay, So I'm going to kind of go back and forth, so hopefully this isn't too obnoxious here. Okay, so let's plot this point. And let me get a color that's different here. And we want the point that represents x equals 5 on the graph. Okay, so we're looking at somewhere here, okay? Okay, so we're going to travel to the right of this point to stay on our function. And as we travel to the right, the x values are getting bigger. Which y value are we approaching? So going back to the graph again, if I start traveling to the right, so I'm going this way, but I'm staying on the function. I'm going. What am I getting closer to? Closer and closer to that asymptote, which is right at 3. Okay, so as the x values increase, the y value is getting closer and closer to 3. Okay, limits. When we talk about getting closer and closer to a certain y value like we just did, we're really talking about limits. And in calculus, you're going to see this very regularly. Using graph 1, complete the following. So that same graph we were looking at, we're looking here as x approaches infinity, f of x approaches 3. So if I put in 100 for x, we're going to be closer and closer to 3. If we put in 2,000, we're going to be closer to 3. So as x, the input gets bigger and bigger, the output is going to approach that 3 value. Okay, here's our graph number 2 with bugs. Bug 1 starts at the point corresponding to x equals 6. So this is bug number 1. Okay, so we are moving to the left. So he is going to travel, stay right on this function, and he's going to go this direction. As he travels along the function, he's going to get closer and closer to what value? And it's this value here. It's the value of 3. The second bug is going to start right here at the point corresponding to x equals -3. So here's this guy's start. And he's moving to the right. He's going to go and go and go. And what is he getting closer to? The output of 1. So what we're going to do is we're going to think about traveling from the right, like bug number 1 here. And we're going to think about traveling in from the left. And we're going to see where are they getting closer to. So this is our notation. So we're going to see this written. This is said the limit of f of x as x approaches c. So there'll be a certain value that we have in mind, and that's what we're looking to find. Okay, if we refer back to graph 1, suppose you're walking on the function and start from the point that corresponds to x equals 5, and we're going to travel to the left. What value do you approach as you get closer and closer to x equals 2? So again, if we're thinking about that graph, and let me just take a peek here on my slides. Okay, instead of flinging you back and forth here. So if we think about that graph, we have the horizontal asymptote here at 3, the vertical asymptote here at +2, and then you had your 2 branches that looked like this and this. Okay, so this is saying, hey, go ahead and you're at the point x equals 5. So that was what you already had plotted. So let's say it's somewhere here. Okay, and I think that was 3 1/3 was the output. Okay, travel to the left. Okay, so follow me. We're walking right along this. We're going. What are we getting closer and closer to? We're getting closer and closer to infinity. So notice I came in from the right, and notice this little plus sign. This is a right-handed limit. So right-hand limit, this is what we call a one-sided limit. So the little plus sign to the right of the 2 indicates a one-sided limit. As you approach 2 from the right, so again, we're coming in from the right, what value do we get close to? Now let's try this with the left-hand limit. as x approaches 2 from the left, that's not a negative 2, that's approaching 2 from the left of the function f of x, this equals what? So let's go ahead and give this a try. So let's say I start here, and I'm coming in and I'm getting closer and closer. Remember, we're thinking of the x values, closer and closer to 2. Where am I headed? Negative infinity. So we're looking, again, this was a left-hand limit. We're coming in from the left, following the curve, and getting closer and closer to a specific value. In this case, it was positive 2. Okay, if we look at this bug graph again, we can see this one is saying the limit of f of x, here's our f of x, as we approach 3 from the right. Okay, here's my bug. Here's the value of 3. So I'm going to go, and I'm getting closer and closer to 3. Now, it doesn't mean what does it equal, right? We're not doing f of 3, because that would give me a different answer. It's saying what am I getting infinitely close to as I approach? That's our right-hand limit. Now, let's look at this bug down here. Oops. So this guy, he's going to travel in. Now, again, we're looking at here from the left. He's going to approach the same number 3. So he's coming in. He's getting closer and closer to what? To the value of 1, this output of 1. Notice these are not the same, and that's what we're going to look at next. First of all, our one-sided limits, these are our definitions you're going to write in your notes. We have the limit of f of x as x gets closer to c from the right. Again, we're traveling in from the right on the graph. And then the limit of f of x as we get closer to c from the left. So we're traveling in from the left. When the left and right hand limits do not approach the same value, we write the limit does not exist, and this is your shorthand for that. So in that last slide, if we were to just, the one with the bugs, if we wanted to say, okay, what's the two-sided limit? As x approaches 3 of f of x. Well, since we already saw that these two things are not equal, we would say, hey, this is a two-sided limit. Notice there's no baby plus or minus. This is a two-sided limit. We checked the right-hand limit, the left-hand limit. They were not equal. So we say does not exist. They have to be reaching the exact same value. Okay, so for this example, and again, please pause me and give these a try. First one is saying the limit of h of x as x approaches -1 from the left. Here's -1. I'm coming in from the left and I'm approaching +1. This B is saying, hey, as x approaches -1 from the right. So I need to come in this way and I'm approaching -2. So the limit of h of x as x approaches -1 from the right is -2. Limit of h of x as x approaches -1. Now, this is where you see, hey, those two, the left and right hand limits did not match. So we say does not exist. Now, what is h of -1? When I actually input -1, my output for this one is this value right here of 1. Okay? It's not the open circle, it's the closed circle. Limit of h of x as we approach 3 from the left. So here's our 3. As we approach, now I'm going this way, as we approach from the left, we're getting closer and closer to 2. This one is saying, hey, how about if we approach from the right? Okay, we'll go down this way. What are we getting closer to? 3. For the next one, this is saying, hey, how about a two-sided limit? The limit of h of x as x approaches 3. Since these two values were different, we have to say this does not exist. And then h of 3 has to be this value here, 2. Okay, for our second example, limit as x approaches negative 3. Now this is a two-sided limit. Notice there's no little plus or minus to the right of 3. So let's look at where negative 3 is. As we come in from the left and we come in from the right, they both approach the same value of 2. So that limit does exist. That two-sided limit exists because they both approach it. It does not matter that that is an open circle. They are still getting closer and closer to the value of 2. The next one is saying the limit of g of x as x approaches 6. Now here's 6. If I come in from the right and I come in from the left, they're both approaching negative infinity. This is also a two-sided limit. Now let's look at a one-sided limit as x approaches 0 from the left. So let's take a look at this one. As we're approaching 0 from the left, we're getting closer and closer to 0. I'm going to skip down to this, I'm going to skip this next one, go to the one after. As we approach 0 from the right, where am I going closer to? To 3. Now, since these two are not equal, the two-sided limit of g of x as x approaches 0 does not exist. Now this is talking about end behavior. Notice we're not going to have a right or left-hand limit as we go to infinity or negative infinity. We can't get to the right of infinity. So this is going to be our end behavior. As x approaches infinity, okay, so let's just approach infinity. Where am I going? My end behavior is infinity. And as x approaches negative infinity, what does this look like? It kind of looks like this might be a horizontal asymptote here. So this would be approaching negative 1 would be the end behavior on the left. Okay, go ahead and write down your criteria for success. Understand and explain one-sided versus two-sided limits. And please remember that infinity is about the end behavior. Okay, so the classwork that you will probably be doing independently in the PDF is pages 9 through 12. If you have the physical worksheets, the first sheet is titled For a Limited Time Only. There's 2 sides for that. And the second sheet does not have a name, but it comes right after it, also 2 sides. I have provided the key for you in Schoology. So when you work on this, I would do some and I would check your answers. Don't do the whole worksheet and then go check it and then everything's wrong and you got to redo everything. So do a little bit and check it. Do a little bit more, check it. Kind of keep going through that way. Exit tickets. Last Thursday when I saw you, I do not think I was very clear about finishing that exit ticket. So I would love for you to still do that, and I'll make sure that it's still open in Schoology. And then also today's exit ticket has been posted in week 2. So this is in week 1 and this is in week 2. Please remember these are not counted in your grade. So you have 2 attempts. Try them without your notes and see how you do, and then you can always go back and check and then try it again. Your results are supposed to tell you if you understand the topic or not yet. If it is not yet, that's when you should be making sure to see me in office hours, email me, go ahead and contact a friend. You guys can work it out together, and we'll be sharing information to hopefully form some study groups as well. Okay, so for next class, I'd like you to try to finish the exit ticket from last week and today. I'd like you to review the syllabus. I'd like you to watch lesson 1.4 and take notes. 1.2 homework, this is and it's called IP, Independent Practice. That will be turned in next Monday. So this is the only thing that is going to be collected on Monday. You can check your work 1.1 with my posted key and use a new color to correct the process and identify any areas that have misconceptions. And I would highly suggest using Wednesday, the asynchronous time, to work on some of the above. And again, I am happy to help you in office hours. So please don't hesitate. Anything that you have questions on, please feel free to come and ask. Okay, thank you for watching, and please let me know the questions that you have.